Welcome to the severe weather analysis for Charleville, Queensland. This is the Friday, December 12th, 2025 morning sounding taken at 10 a.m. local time. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. This morning's sounding shows minimal mixed layer CAPE of just 22 joules per kilogram, essentially sub-convective conditions. The atmosphere is stable with a moderate capping inversion between 917 and 694 hectopascals. The surface temperature is 26 degrees with a dew point of 18 degrees, giving us a modest 7-degree spread. However, the most unstable parcel shows 1239 joules per kilogram of CAPE, indicating there is instability present at the surface level, but it's being held down by moderate convective inhibition of 57 joules per kilogram. With storm relative helicity of 54 meters squared per second in the lowest kilometer and 214 in the lowest 3 kilometers, we have some low-level rotation potential, but without sufficient CAPE, storm development is unlikely this morning. Looking at the afternoon transformation on our heated skew-t plot, we are forecasting a maximum temperature of 37 degrees Celsius. This solar heating will dramatically change the atmospheric profile. The mixed layer CAPE surges from 22 joules per kilogram this morning to 1099 joules per kilogram this afternoon. That's a 50-fold increase in available energy. Notice on the enhanced plot how the blue shaded area showing CIN, the lid holding everything down, remains present but weakens. The red and pink shaded areas showing CAPE, the fuel for storms, expand significantly as the heated parcel path diverges from the environmental temperature profile. The cap break temperature is forecast at 28.6 degrees Celsius, and with a forecast max of 37 degrees, we have very high confidence at 95% that the cap will break. If storms can initiate, the wind shear of 27 meters per second over 6 kilometers provides favorable conditions for organized multicells or possibly supercells. The hodograph reveals important information for emergency services planning. We are seeing 0 to 6 kilometer bulk shear of 27 meters per second with notable clockwise curvature through the mid-levels. The right mover bunkers storm motion vector points toward the east-southeast, meaning if supercells develop, they will track in that direction. The 0 to 1 kilometer shear is weak at just 2.7 meters per second, limiting low-level rotation potential. However, the combination of 27 meters per second deep layer shear and potential CAPE over 1,000 joules per kilogram supports organized severe thunderstorms capable of producing large hail and damaging wind gusts. If storms develop, electricity restoration crews should consider prepositioning in areas east and southeast of any developing convection. The hodograph structure favors multicellular storms rather than discrete supercells, suggesting a line of storms with rotating updrafts is more likely than isolated rotating storms. The atmospheric refractivity profile, which shows us the Brunt-Weissaler frequency or n-squared values, reveals important downdraft characteristics. We are seeing elevated duct conditions in the lowest kilometer, shown by the orange shaded band near the surface, which indicates a stable layer that can trap and channel microbursts horizontally. Above this, the profile shows relatively high n-squared values through the mid-levels between 2,000 and 6,000 meters, indicating moderate atmospheric stability in those layers. This profile, combined with our DCAPE of 1225 joules per kilogram and downdraft velocity potential of 49 meters per second, suggests that if storms develop, they will produce intense downdrafts. The high evaporative cooling potential in the dry subcloud layer could generate microbursts with localized severe wind damage. Emergency services should prepare for possible intense downdrafts exceeding 90 km per hour near the surface if organized thunderstorms develop this afternoon. To summarize, Charleville faces a conditional severe weather situation today. Morning conditions are stable, but afternoon heating to 37 degrees Celsius will likely break the cap and release over 1,000 joules per kilogram of mixed layer CAPE. If storms initiate, strong wind shear supports organized multicells capable of large hail and damaging winds. Tomorrow looks stable with sub-convective conditions. Always consult the Bureau of Meteorology for official warnings and forecasts. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.